The chemistry of nitrogen.
Welcome to all NSSC Advanced Subsidiary Chemistry learners and everybody else interested in chemistry. We appreciate your company. From NAMCOL, the Namibian College of Open Learning, we have a series of 5 radio lessons on different interesting topics in your Advanced Subsidiary or AS Grade 12 Chemistry syllabus. In Lesson 1, we discuss the framework structures of crystalline solids. Then in Lesson 2, we submitted 4 Group 2 elements to experiments to see how they reacted to oxygen and water. Lesson 3 saw us sweating over the relative masses of atoms and molecules. Today in Lesson 4, the chemistry of nitrogen and its application in industrial and organic fertilizers. If you are a NAMCOL student, you will find this topic in your textbook, AS Level Chemistry Learner's Book, in Topic 3.5.1 on pages 191 to 196. So, in this lesson, we will explain the slow reactivity of nitrogen and will discuss this in relation to the need for industrially manufactured ammonia and ammonium salts for fertilizers. We'll also explain the environmental consequences of using soluble synthetic nitrate fertilizers, including their rapid leaching, eutrophication, and possible contamination of drinking water. Finally, we'll discuss what benefits exist in using organic fertilizers instead. Please join us. Ushona, my student, is here as well.
Good day, Miss Polton. Hi, learners. Miss, is somebody else using the classroom? You told me to wait for you outside for the class.
No, Ushona, there's no one in the classroom. But I wanted to bring you to the school garden for us to discuss an important topic.
That's intriguing. Oh, look, Albert's lawn has brown spots. I wonder why, miss.
Okay, Ushona, we didn't really come to water the garden today, so please pay attention. Look at that vegetable garden. Tell me what you see.
Oh, those vegetables are not so happy either. Their leaves are turning yellow. What could be the problem?
Albert says they lack nutrients.
Ha, nutrients. But they are plants. What nutrients can they want? I thought a plant only needed water and sunlight for photosynthesis.
Oh no, plants definitely need nutrients to grow properly.
Yo, now I've heard everything. What nutrients do they need? Protein, vitamin B, what?
You should spend some time helping your dad in the garden over weekends, Ushona. One of the first things you will learn from him is that plants need fertilizer in the soil. Fertilizers are what feeds the soil with different types of nutrients for different plants. Some plants like acidic soil, others alkaline, and so on. But all plants need nitrogen, and nitrogen is therefore a major important ingredient in most fertilizers. It will surprise you to hear that, yes, nitrogen is also a major component of all proteins. All living organisms need it in order to grow and stay healthy. In fact, it's a major component of the bodies of humans, plants, and animals.
Ah, but wait a minute. I remember learning that nitrogen makes up about 78% of the Earth's atmosphere.
That's right. That should really show you what a major nutrient it is for all living organisms.
But what I mean is, why don't plants just use it straight from the atmosphere?
It has to do with the structure of nitrogen. Nitrogen is a diatomic molecule with a triple bond. Diatomic means 2 atoms, right? Because nitrogen does not occur as a single element N, but as N2 with a small 2 below the N when you write it. And when this N2 molecule bonds with another one, it forms a triple bond. The problem with this strong bond is that it's too strong to be easily accessed for use by plants as a nutrient. Fertilizers must be soluble into the soil and water and must contain readily accessible nitrogen. So, some processing is necessary in order to make it more accessible for the plants.
I don't understand, miss. You said nitrogen is used as a fertilizer, but now you're saying it is too strongly bonded to be accessible for plants? So where do fertilizers come from?
Remember that I also said nitrogen becomes accessible to the plants once it is processed into fertilizer.
Oh, you mean they do something to the natural nitrogen to make it soluble into the soil and water, and then it is suitable as fertilizer because the plants can then access it?
Yes, they use another chemical compound, ammonia, to achieve this. Nitrate fertilizers such as ammonium nitrate can be synthesized or made by making ammonia react with nitric acid.
And is ammonia also on the periodic table?
No, ammonia is a compound made by reacting nitrogen and hydrogen in an industrial process called the Haber process.
Haber process? That must be somebody's name.
Probably the guy who invented or developed the process. Anyway, the ammonia is then used to make fertilizers by reacting it with an appropriate acid. Ammonia, which is a weak base or alkali, reacts with the acid to form ammonium salts, and that is the fertilizer. The nitrogen cycle helps to explain this. Do you remember what the nitrogen cycle is?
I think the nitrogen cycle explains how nitrogen moves from the atmosphere to Earth, through soils and back to the atmosphere.
Now then, plants take up nitrogen from the soil in the form of nitrates. Bacteria in the soil break the strong bonds in nitrogen gas from the atmosphere through a process called nitrogen fixation. Nitrogen-fixing bacteria live in the soil or in root nodules or legumes like peas. So the bacteria decompose the protein in dead plants and animals into ammonia. The ammonia is then converted into nitrates, and finally the nitrates are converted back to nitrogen gas.
That is an interesting cycle. So it is quite possible for this process of breaking down of nitrogen to occur naturally or organically, so that a complicated chemical process is not really necessary.
That's true, but the organic breakdown is slower. However, it is also a fact that using too much chemical fertilizer is not good. The overuse of chemical fertilizers can cause environmental damage such as contamination of drinking water when the chemicals leak into boreholes and rivers near a homestead. This is called eutrophication. Eutrophication happens when an excess of chemical fertilizers are used which dissolve in water and leak into sources of drinking water such as lakes and rivers. This stimulates the growth of organisms causing algae bloom. Algae bloom causes the blockage of sunlight, resulting in water plants being unable to photosynthesize and produce oxygen, so they die. It also causes fish to die and dead zones in the lakes, rivers, or oceans. The overabundance of algae and plants sets off a chain reaction in the ecosystem. This matter eventually decomposes, producing large amounts of carbon dioxide, which in turn lowers the pH of seawater to cause ocean acidification. Acidification slows the growth of fish and shellfish and can prevent shell formation in bivalve mollusks. This leads to a reduced catch for commercial and recreational fisheries, meaning smaller harvests and seafood become scarcer and more expensive.
Sure, people can harm their own food sources, ne, miss? I now remember learning about eutrophication, which causes plants to die in the water because the increase in bacteria causes oxygen in the water being used up, causing in turn death of aquatic life such as fish that depend on this oxygen.
So let's remember the use of less fertilizer and being careful with its application are best for reducing these problems.
Miss, I'm just wondering, how does the manure that many people put in the garden soil affect the plants?
Well, manure comes from biological waste, from humans, horses or cattle. So it's an organic fertilizer. It's less soluble in the soil and water than the chemical product, so nutrients are released at a slower rate. This is good, not bad. The slower release of nutrients results in minimum nutrient loss to the environment.
That's good to know. Organic fertilizer is not only better for the environment, it's much cheaper.
That's right. I hope you learned a few things about nitrogen today, which is not simply a theoretical lesson, but which you can apply in real life.
I sure did. May I continue to water the garden now?
No, it's too hot at the moment. It's better to water it early in the morning. But what you can do is tell me what you have learned.
All right, I'll summarize for the learners. We heard that about 78% of the Earth's atmosphere consists of nitrogen, but its triple bond is too strong for plants to use it directly as a nutrient. However, nitrate fertilizers are soluble and contain readily accessible nitrogen. Nitrate fertilizers are made using high heat and pressure, where atmospheric nitrogen and hydrogen are combined to form ammonia in an industrial process called the Haber process. This ammonia can be further processed into ammonium nitrate that can be added to soil and used by plants. During the nitrogen cycle, nitrogen gas is converted into nitrates by nitrogen fixing bacteria.
Oh, sorry to interrupt you, Ushona, but do you know nitrogen can also be fixed by lightning? Lightning contains a lot of oxygen, which form oxides of nitrogen, which then wash into the soil to be absorbed by plants. That is why plants grow exceptionally well after a good rain shower. It's not only the water they get, it's also the nitrates from lightning. And when plants die, the protein in them is decomposed to ammonia.
Oh, wonderful creation.
Indeed. But please continue, Ushona.
When the ammonia reacts with water, ammonium is formed. Nitrification also happens when ammonia is converted into nitrates, which can be further converted into nitrogen gas. But an overuse of nitrogen fertilizer creates an environmental problem, where these chemicals can leach from the soil into groundwater sources, including rivers and lakes. This is known as eutrophication. A bloom of algae can spread across the water surface, blocking out the light so that the plants die. And when they die, bacteria in the water feed on them to decompose the plant material. The bacteria multiply rapidly with so much food available, using up the dissolved oxygen in the water, and without oxygen in the water, the fish die.
That's very well explained. Thank you, Ushona. I will continue. Nitrates have been detected in our drinking water. This is not good for our health, as it is poisonous. Organic fertilizers are less soluble, so nutrients are released at a slower rate, resulting in minimum nutrient loss to the environment. Using organic fertilizers are better, as it causes less toxic buildup of chemicals in the soil. Now let's wrap up. Learners, please also remember that NAMCOL has many more radio lessons that can help you brush up on your school topics. Thanks for tuning in and join me again soon.
Wait,
Again, Ushona, what now?
please, miss, a joke.
You go then.
Thank you, ma'am. Knock, knock.
Who's there?
Ammonia.
Ammonia who?
I'm only a little boy who cannot reach the doorbell. That's why I'm knocking.
Listeners, please excuse my student. She's a jokes junkie.
This lesson is produced by NAMCOL with funding from the Ministry of Education, Arts and Culture.